one of your specialties, as we've talked about, is tracking migration movements. White front geese is the one that I'm familiar with, but what are some of the latest tools? Are there other tools that you've used more recently? Other, like cameras, drones, transmitters, what's some of the cool tech that you've been using or interested in, and what are some of the advantages that offer us?
Sure. Yeah, drones are certainly one of them that I'm excited to get a little bit more use out of at Delta here. I haven't used them in my own program as extensively, but Delta has done a wonderful job developing drone technology for use in brood detection and brood abundance monitoring, and a few students working on that right now. It's really exciting stuff for an area of our field that broods have always been really tough to study. And so this is it's really exciting to start incorporating that and really understanding brood ecology. In terms of transmitters, transmitters, everyone's seen these now. Like they're small backpacks. They collect unbelievable data. You can get sub-minute data in some circumstances if you want to, a GPS location. But one of the cool sensors that not many folks are using, but we're trying to increase that right now, is called an accelerometer. And an accelerometer, you've all got one in your cell phone and on your smartwatch. It's a small device that essentially measures acceleration, movement in any direction, and through a suite of, so that's in the transmitter. And we get one of those readings. You can get them every couple of minutes. So in most of our projects, we get an acceleration reading every 6 minutes. And what we do with that acceleration is you can do a couple of things. One of them is you can understand waterfowl behavior specific. So like with through a suite of machine learning models and known video footage of these things, of birds in the wild or in captivity tagged with known behaviors, right? You can apply it through statistical algorithms to wild birds. And so every 6 minutes we can tell whether that bird is walking or stationary or it's feeding or it's flying. And you can really build out kind of unbelievable data sets of, you have the GPS locations, and you also know what they're doing, where they're doing it. And so we've published a couple of papers on this now, but I think it's starting to gain a bit more traction, and the power of not only understanding where they are, but what they're doing when they're there is a really powerful tool, and can help lots of folks understand how to better manage these waterfowl. The other thing it can do, there's a metric called overall dynamic body acceleration, which is in the literature, it's a proxy for energy expenditure. And so this accelerometer uses those values to calculate overall dynamic body acceleration. And we're in the process right now of developing predictive layers of energy expenditure on the landscape, and you can see where it's really high and where it's really low, and thinking about how land managers, whether they're private land owners who have a club and are doing moist soil management in the south, or federal agencies on refuge, whoever you are, looking at how waterfowl energetics occur on your landscape could really play a big role in how you think about managing your landscape in different scenarios. And what if we plant this here and that there to help reduce energy expenditure? So it's a lot of potential that's really kicking off.